Hello and how are you? Welcome to this tutorial in which we are going to handle a revision of the completing square method. And I am your tutor Joseph Madeli. Before we begin, we shall have a quick word of prayer. Father Lord in heaven, you being the greatest mathematician, we invite you in this session that you may be able to guide us as we plunge into this session of revising completing square method. Teach us, Lord, in the smith of your voice. This may pray. Amen. Now, we'll quickly go to our specific objectives to be able to know what are we aimed at and what we need to know. By the end of this tutorial, you should be able to do the following two things. One, master the completing square concept. And number two, I shall leave it to your question. What do you think might be the second objective, or what might I be yearning you to understand by the end of this tutorial? Sit back, friend, and we shall be able to journey together. I shall request you to be active in this session, though how passive it shall be from my side. I shall be the one teaching, but I pray that at the end of the tutorial you shall be able to be enlightened in this session by two objectives. That one, you should be able to master the square concept, completing square concept, and also the second objective, of which now I'm leaving it up to you to be able to unleash by the end of this tutorial. I pray that you have your pen and paper with you and work on very fast and scribble something. And by the end of the tutorial, have in mind of what the objective is before I give you the objectives, because we may not have that chance to interact openly. But allow me begin directly. Now, question. Using the completing square method, solve the following quadratic equation. That's ax squared plus bx plus c is equals to 0. Now, if you don't mind, you can be able to pause the video and try on that question using completing square method. Now, I believe you have something to be able to give in this session as an answer. So this is my work in here. We shall do it step by step, also run in parallel to what you shall be having. Step 1. Ensure the coefficient of x squared is 1. Now, this is the equation that we have. What do I mean by the coefficient of x squared to be 1? The coefficient of x squared is this, is a. A is the coefficient of x squared, and it must be 1. So we shall be able to do something. What do you think might be done? To have it as 1, we shall be able to divide that coefficient by itself so that it gives 1, because any number divided by itself gives 1 as the result from mathematics that we have been learning all through. So basically, we shall be able to divide all through by a. So after dividing all through by a, we shall have the following equation, whereby we shall have x squared plus b over a x plus c over a is equals to 0. So that is the first step, ensuring the coefficient of x squared is 1. Next, step 2, collect the like terms and have them on one side, that is on the left or either on the right. So we shall be able to do this in this particular next step. We know that our equation is x squared plus b over ax plus c over a is equals to 0. Basically, what are the like terms here? The unknown is x, because that's what we are solving for. Now, if you're solving for x, which is the unknown, we notice that x squared plus b over ax are of similar terms. They both bear the unknown. But c over a is what we call a constant. so it doesn't bear any unknown. So because it's not a like term with the others, we shall shift it to the right side of the equal sign, and by that we shall be able to have collected all the like terms. This is what I mean. We shall have x squared plus b over ax is equal to negative c over a. Let's go to the next thing. Step 3 introduced a constant. Now I believe from your high school level up to that point you shall now start saying multiply the coefficient of x by a half. Now it's right, yes, but someone may ask you, then where did you find that a half? I'm only saying that because I have not included it in the slides because I want to teach a professional way. So that step that you're told in class is also right, but it bears many assumptions that you just have to multiply a half. What if I multiply a quarter? Will I be right? Now, here is the answer. Introduce a constant k. Now, let's go together so that I'm able to understand. So don't cancel your method that you multiply a half saying that it's wrong. No, it's right. Only that I now want you to be able to be more educated. So this is what we have. X plus b over ax is equal to negative c over a. We introduce a constant. And basically what you introduce the constant, what you do on the right hand side, you must do on the left hand side. But here now I'll introduce them as one block. What I mean on one side. Let's see what I mean. This is what we shall have. X squared plus b over ax plus k minus k is equal to negative c over a. Notice the negative k, when moved to the opposite side of the equal sign, it shall be positive. So what I've added on the left hand side shall be added on the right hand side. So it's quite okay. So I believe up to there we are right. Now, we shall now proceed to simplify this equation that we have been able to create or able to get, which is basically x squared plus b over ax plus k minus k is equal to negative c over a. This one shall be able to tell you that what you have done on the right hand side, you have done also on the left hand side, which is basically x squared plus b over ax plus k is equal to negative c over a plus k. So what you added on the left hand side, I was added on the right hand side, which was constant k. So far so good. Now, from the various facts about perfect squares, sorry for that double statement, which we shall look at just in a moment, we shall make an assumption that the equation on the left-hand side is a perfect square. The equation on the left-hand side, which was basically x squared plus b over ax plus k. That equation, we shall make an assumption, which we are allowed as scientists and also mathematicians to do. We shall make an assumption that it's a perfect square. And I believe you know factors about perfect squares. You can just start scribbling them, facts about perfect squares that you know. But I shall apply one of them here so that you're able to understand what we mean, or quite a couple of them. Now, with the knowledge on perfect squares, we know that b squared is equal to 4ac. That's an equation that you should always remember. It shall always follow you. So this is from the form of quadratic equations. We may ask, what is b, by the way, and what is ac? If I have my format of the quadratic equation in this particular form, a is basically the first coefficient, or basically the coefficient of x squared. C is the constant. B is the coefficient of x. So that is where we source b squared and ac from. And 4 is basically a constant that is usually in that formula. Therefore, from that, we shall be able to say, if it's now substitute, in our case, we find that the coefficient b that we have in our equation is basically b over a. And we need to square it, which will be equal to 4 multiplied by the first coefficient, which is 1, multiplied by the constant, which is k. So we shall end it to k is equals to b over a squared over 4, which will be equal to b over a squared multiplied by a quarter, which is basically, from indices, we can derive that as b over a squared multiplied by a half squared. Now, because the powers are the same, we can basically multiply out the bases, which will basically come to b over 2a. So that is basically what we can be able to salvage up to this particular point. So k is basically equal to b over 2a everything squared. Next, let's substitute the value of k into our equation first. So if we substitute, we shall have the following: x squared plus b over a x plus b over 2a squared is equal to negative c over a, and we had k on the right hand side, which is b over 2a squared. That's what we have up to that point. Notice we assume the right hand side to be a perfect square, so let's prove it to be so. This is the part that we assume to be a perfect square. Let's prove it to be so if we got it right with our assumption. So something you need to note, we shall pause here and speak something that shall help us in this course. Let's speak about perfect squares in a moment. That's basically what we want to look at. We start on some facts about perfect squares in a moment. A perfect square, what is it? It's basically a number or expression that when simplified bears square factor. We shall look at an example so that you're able to appreciate what the square factor is. It's also called square number. A perfect square bears the following form: x squared, a plus b, everything squared, is a perfect square. What we meant by the square factor, let's use a different color. This is what we term as the square factor. Anything raised to power 2, that's the square factor that I simply termed it as. And notice if it's a square, because if I rewrite this, it will be a square. You know, it's a number multiplied by itself. That basically gives us what we term as a square. But in this next one, this is not a square because they're not similar. They are different expressions. But a square is basically a plus b in brackets multiplied by the same number again, a plus b. That's a square, a perfect square, or basically a square number. So that's basically what we know as perfect squares. It must be written in a it must bear the square factor in it. So let's get something else. Now let's get this down to work from what we have just been able to see. Step 4, we now start by solving the equation from what we understood by perfect square. Now x squared plus b over ax plus b over 2a everything squared is equal to negative c over a plus b over 2a everything squared. Let's solve this. We shall have this if I open up everything so that I'll make the square part and so have everything as an individual term. So it will be x squared plus b over ax plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. I believe you can see how everything comes about. Basically, what I've simply done is that we had these square factors. I basically now opened up these fractions and the brackets. I solved them out. Now we know that if you want to solve the quadratic part, we normally have the product and the sum steps. So we shall ask ourselves, what is the product and what is the sum? Basically, it is quite simple. The product, you shall basically check it by checking the coefficient of a, of x squared, multiplied by the coefficient by the constant, which is basically b squared over 4a squared. What about the sum? The sum is basically picked as the coefficient of x. That's basically what it gives us as the sum, which is basically b over a x. Okay, sorry for the x part. It should not be with x. It should just be the coefficient part. So sorry for this. Eliminate the x part. So if I continue, what two factors shall be able to give me b squared over 4a squared? You'll notice that it is b over 2a and b over 2a. If you square these two, gives you that, and if sum the two, gives you b over a. Forget the x part. It's a wrong statement there. So basically, if you multiply that, you shall be able to get b over a squared. And if you sum the two, you shall get b over a, not b over x. You can correct that. So let's simplify out our statement. X squared plus b over a x plus that, everything, that particular manner, you shall be able to simplify it out in this particular way. This is what you shall have if you simplify it out. And the further you simplify it more, you'll notice that there's a repetition of products here. And if there's a repetition, it means it can be written in a square manner. So this means the left-hand side is a perfect square, as we made the assumption. But what we need to do now is to simplify also this, have a one fraction. So let's do that right away. We shall be able to have the following. In the right hand side, we shall have this particular fraction, this. And the next step, we shall be able to get the square roots on both sides. If you get the square root on both sides, you shall be able to sum up to this, whereby you shall have x plus b over 2a is equals to plus or minus. Now, why do we have plus or minus? Any number, in quadratic formulae, you shall have two roots as your solutions of x. So if that is the rule, the square root of any quadratic formula will give you two answers, either positive or negative. That's the assumption given. So in this case, it shall either be positive or negative. So because we are looking for the answer, the value of x, we shall make x the subject. So the next thing shall be making x the subject, of which, if you make x the subject, that's the next formula that you shall have. And if you simplify it further, you shall be able to get this. Now, I believe things are starting to look familiar somewhere, but I'll not tell you what are you seeing familiar until when you reach there. Now, let's make this equation the one you usually know, because this is our solution. This is our answer, by the way. But this is what you know. I believe if I got the next statement, I'll be able to get it. But how do you usually know this statement to be beautiful? How do you usually know it to be? I believe this following statement is very familiar. Is that unfamiliar to you? I believe you can now start smiling and be able to figure out what I was looking for when I gave you that particular question and made it as a way of revising completing square method. So basically, the answer of x is that. And something that you can notice, I was aimed at a particular direction. Where was I aimed at? Let's please find out. So this is the solution for x. This shall give you the solution of x. Now, back to our specific objectives. By the end of this tutorial, you should be able to, one, master the concept of the completing square concept. I believe that when you have mastered and you have tried to follow up. If not, please go back and be able to get it well. But what was the second objective? I believe the previous slide can be able to tell you what my objective was by giving me this question. I suppose you guessed it right and got it. I was basically deriving the quadratic formula, and I believe you have been able to follow and you have known how to derive the quadratic formula. Otherwise, success in your preparation. God bless you abundantly.